In this video, we're going to go over problem 2 from lecture 2 on the money plots. In this case, we're going to do two different things. So one, we want to try a couple different rates. So instead of just plotting one rate, we're going to try 2%, 3%, and 4%. And the other thing we're going to do is add a target line so that we can draw when we hit that $12,000. So a couple changes to the original script. As you just saw, R has three numbers in it now, it's an array, and T is now going to go to 10 years because otherwise we won't reach our rate goal. So this is a typical MATLAB ease type thing to do in order to be able to create a line that goes across at 12,000. So if we want to plot a line, we have to plot once for each t value, and we have to plot at a height of 12,000. So what we're trying to do is make this red line up here. So there's a couple different ways to do this. This one says I want to make it an array, and it's got to have the same number of elements as t, so we can plot against t. And I'm going to use zeros to make this array. So zeros is a command that makes an array that has this many rows and this many columns. In this case, we want one row and this many columns. And in order to get it to be 12,000 instead of 0, we simply add 12,000. So this is a typical MATLAB-ease type way to make an array in this way. All right, so one thing to note here is that if we just try to do this amount times 1 plus r times t, this isn't going to work anymore because r is now an array and t is now an array, and these arrays are different size. So you can't just plug this in and have it work. And it kind of doesn't make sense anyway, because you'd be taking an r value of 0.02 and multiplying it by the first year, and then 0.03 times the second year, and so on. So that's not going to work. So for this week, we're going to do this by hand, and I'm going to set you up for next week when we're going to do this all with a for loop. But for now, we're going to do it by hand, one piece at a time. So there's a couple other things we need to do. So we want to make three plots, one for 2%, one for 3%, and one for 4%. So in order to do this, we need a command called subplot. Subplot takes in however many rows you want, however many columns you want, and which of those three plots you want to plot in. So a little bit of setup here again. So I'm actually going to declare a variable called n rows and a variable called n columns. I highly recommend this because otherwise you end up, if you change the number of plots, going through and taking and having to change each of these by hand. By setting these up as variables, you can just set them here and you're done. And you'll notice the other thing I've done is I've said I want as many columns as there are r values. Now the reason you do this is so that if we decide we want to try another rate or a fewer rates, we don't have to go through and fix this variable. It'll already be the right thing. Now this is something that we'll see again later. So which window you plot in is going to have to be a number, 1, 2, or 3, because there are three windows here. So one way to do this is to set this variable to be 1. And then you'll see down here I add 1 to it. So what I'm going to do is I'm going to say 1, I'm going to do subplot, I'll do my second subplot down here, and this will now be 2, and so on. So again, this is setting up for loops next week. Same equation we've been doing before, but you'll notice this. So if I just put r in here, like I said, this will break. But if I take r and I say give me the first element of r, then this is one number, and this whole equation still works. Okay, so now we can plot our t against our a like we've been doing before, and that will give us this plot like we've been doing before. This target line, that red line, so here we're just going to take t and we'll plot with target. And remember, target we've already set up cleverly to have the same number of elements as t, and it's all the same value, so you get a straight line out. One more tricky thing here, see this sprintf instead of fprintf? Sprintf is exactly the same as fprintf, except it creates a string instead of outputting to the command window. So what we've done here is we want to title our plots with the actual rate value. So in order to do that without hardwiring all these numbers in, we're going to do rate, and it's the same %0.2f, and it's going to grab the value from r1. So when we do this now, our title cleverly says 0.02%. All right, now we're just going to rinse and repeat. We increment our subplot variable, and we're going to do the exact same thing we just did, cutting and pasting and copying our code, except now we're going to do R2 instead of R1. As I said, next week we'll figure out how not to do this. But for the moment, we'll just do this. And then we'll do it one more time with our third rate. And what we get out is 3 plots, one for each rate, and with a red line that says this is where we want to, this is when we're going to actually get to our goal of $12,000. So in summary, the things that you should notice in this script is 1, accessing individual elements of R in order to build our plots, this setup for subplots with this iPlot index, and we'll come back to that again next week, and this one other trick for target as a way to make an array of a given size with this value.